The finite element simulation of a steel cantilever beam under a point load. The deflection of a cantilever beam under a point load applied at the middle of the span is simulated. During the test, the fixed end will have zero displacement, and tension will exist above the neutral axis, while compression will exist below the neutral axis.
To solve the Euler-Bernoulli cantilever beam as a fourth-order boundary value problem, consider the expression shown in domain 0 to L. The boundary conditions are at x equal to 0, the displacement and angle of displacement are equal to 0, and at x equal to L, the force and moments are equal to the expression shown below. To solve the boundary value problem, we use the weak form by weighted residual method.
Cubic Hermite functions shown are used to derive an elemental stiffness matrix for the cantilever beam. From here, a global stiffness matrix is generated as well as a global force vector. The global stiffness matrix is multiplied as an inverse by the global force vector to obtain the displacement. The displacement is plotted here.
A similar 3D model of the cantilever beam was made in Abacus, and the deflection versus the distance from fixed end was plotted for 101 nodes, and the resultant plot were compared with that of the MATLAB outputs. Here are some of the plots of the midpoint as well as the free end about the deflection.